Alright, here's the 12-4 homework. Even problem, starting with problem 10. Alright, the limit as x approaches infinity of 4 over 3x. That's 4 over 3 times infinity is just infinity, minus 5. And 4 divided by infinity, that's just 0. Because 4 divided by a huge number gets so small that it's basically 0. And so we get negative 5 as our answer. Use a graphing utility to verify this. Let's jump over to the graphing calculator. And in our y1, we've got 4 over 3x. Four divided by, I'm going to put the 3x in parentheses to make sure that we're dividing by the whole thing. And then we're going to minus 5. Go ahead and graph this. Let's see what this looks like. And it's dropping down like that. We're going to need to zoom out just a little bit. Let's change our window here. Negative 10 to 10. And actually, since we're going to infinity, let me make this bigger. Let's see what happens as the x value gets really big here. Let's graph that. And when it's done, we'll do a zoom fit to adjust the y's appropriately. So it drops down, and you can see what happens here. If it's zoomed in, it's dropping straight down, and then it's flattening out, flattening out, flattening out. If we trace, and we move along, what's happening to that line? Negative 4, 9. And you can see it's getting smaller and smaller, slowly closing in on negative 5, which was what we thought should happen. So we verified that. Let's go ahead and verify 12. Well, first we'll do it algebraically. 1 plus 5x and 1 minus 4x. As this goes to infinity, we don't care about those 1's anymore at all. Let me pause this. Alright, sorry about that. PowerPoint decided to freeze up on us, but let's check this out. As we go to infinity for 12, we don't care about the 1's anymore because as x gets really big, it's not going to impact our number at all. So we're going to have 5 times infinity over negative 4 times infinity. So those infinities are going to cancel out, and we're just going to be left with negative 5/4 as our limit. Let's check out and make sure that works. Back to the graphing calculator. Y equals, clear this off. And we've got 1 plus 5x in parentheses divided by 1 minus 4x. And let's go ahead and graph this. And we'll zoom fit here as soon as it's done to adjust our y values. And there we go, it's zooming in on. Let's hit the trace. Let's see what's happening. As I scroll off to the right here and make my x's bigger, 600 and bigger and bigger and bigger and bigger and bigger and bigger and bigger, you can see what's happening to our y values, negative 1.25, closing in on that, which is 5 divided by 4. So we're in good shape. All right, moving right along, let's take a look at 28 on this one. Okay, we can deal with this plus. We can do it in 2 parts here. First, we'll look at the first fraction, infinity over 2 infinity plus 1. Do we care about the 1? Nope, it's not going to affect infinity at all. And we can put a 1 up here because the infinities are going to cancel. We'll be left with 1/2 plus 3 infinity squared over infinity minus 3 squared. Infinity minus 3, we don't care about that 3 there. So we've got infinity squared divided by infinity squared. Those will cancel, and we'll be left with just a 1 on the bottom. So 1/2 plus 3 gives us 3.5 is our answer here. Let's check and make sure that we agree with that. A little more work in our graphing calculator this time, just to make sure we've got this correct. So we've got big parentheses, x divided by 2x plus 1. 2 parentheses, and plus, big parentheses, and our first one is going to be 3x squared divided by x minus 3 squared. and then closing parentheses. Go ahead and graph it. Go ahead and do our zoom fit. And it's dropping down here. We'll go ahead and trace it. And as we increase our x values, our y values are getting closer and closer and closer to 3.5. As we move out here, it's slowly getting smaller and it's zooming in on 3.5. So same thing we want to do here on 30. On this one, right away you should be able to see that our answer, 4 goes away, infinity squared divided by infinity squared, that's going to cancel, and we're just going to be left with y equals 1. Okay? So on this one, it says make sure that our horizontal asymptote corresponds to this limit. So we'll go ahead and graph it. X squared divided by x squared plus 4. And it's right up there at the top, but let's hit trace, and as we move sideways, yeah, we're getting closer and closer to 1 with our y values. So again, it works out. Alright, so 32, I'm going to stop doing the graphs on all these. I think you can see how to do the graphs. You can check those based on the previous videos. Let's just go ahead and find out what the limit here is. This is going to be y equals 2 times infinity plus 1 over infinity squared minus 1. Don't care about the 1s. And at this point, infinity squared is way bigger than infinity. So we're going to have a huge number on the bottom. If we divide by a huge number, we get 0. Alright, so on 32, our limit would be 0. How about 34? 2 plus 1 over x as x goes to infinity. So this is 2 plus 0, which is just 2. For 36, it says let's fill in the graphs here. So for 36, we're going to have 10 to the 0 is just 1. So 3, 1 minus 9 times 1 squared plus 1. 3 minus root 10. And so what is that? Let's check on the calculator. Actually, let's go ahead and just put this into the y equals and do a table instead of having to repeat this over and over and over again. 3x minus the square root of 9x squared, where are you? Squared plus 1. Alright, and we can go to our table, but let's do our table set first. We want to start at 1. 10 to the first is 1, and let's count by 10. Just so we can grab the first 2. So the first answer is, oops, let's count by 9. So we can see 1 and 10 at the same time. So 0.1623, 0.0167. Alright, let's get 100 and then 1,000. 100 is 0.0017. Were there negatives on these ones? Yes. So negative 0.0017. Negative, we can do 10 cubed. Which is 1,000. We get negative 2e to the negative 4th. Okay, so as you can see here, we're getting smaller and smaller and smaller, and so our limit here is going to be 0. All right, and we can go ahead and confirm this graphically. Let's go ahead to our graph and do our zoom fit. Hard to see exactly what's going on here, but as we move out, our number is getting smaller and smaller and smaller and smaller and smaller and smaller and smaller. We're definitely zooming in on 0. Alright, so 38, you're going to do the same exact thing on this one. So let's go ahead and plug this into our y equals 4. X minus square root of 16x squared minus x. Alright, we'll start with 1, and I'll count by 9 so I see 1 and 10 on the same table to start. 0.5087, 50807, and 0.50078. I think right away you can probably guess what we're approaching. Let's put a couple more values in there real quick. And how about 100? 0.50008. So you can see right away that we are approaching 0.5. And let's go ahead and look at the graph just to verify this graphically. Finishes up thinking. Do our zoom fit. And what are we closing in on? Let's hit our trace. And you can see here that our number is getting smaller and smaller and smaller, but never smaller than 0.5. Alright, so we'll finish up with some sequences here. This works exactly the same way. We'll do our first 5 terms. So if we plug in 1, and we can do a table here. N and AN. 1, 2, 3, 4, 5. And you know what? Let's do this on the table just to save a little time. Y equals 3n, or x in the calculator's case, over x squared plus 2. And we'll start at 1 and count by 1s. And let's see what the table says. So 1 is 1, 2 is 1, and then 3 is 0.8, 4 is 0.66, and so on and so forth. All right. And so let's go ahead and see if we can figure out what this graph is approaching. N over n squared. I think you should be able to tell me right away what this is approaching. It's approaching 0. What if we counted by 50s? You can see as we get really big, we are getting closer and closer to 0. And we'd eventually get there. So the answer here on 40 is indeed 0. Alright, last problem, 42, and you should be able to tell me right away what the answer here is. The answer is 4. Let's go check out our table just to make sure that we agree with that. 4n minus 1. Divided by n plus 3. Alright, so first we want the first 5 terms. So start at 1 and count by 1. And so here's your first 5 terms, 0.75, 1.4, 1.8, 2. Etc. all the way up to 2.375. And if we kept going forever, let's count by big numbers now, by 100. You can see that really quickly we're closing in on 4. And closer and closer and closer, but never quite going to reach 4. But getting awfully close. Alright, so that's it. That's all there is to 12.4. Any questions? Ask me in class.